We are now live from downtown Mill Bay. And a quick attendance. Uh-oh, it says no internet connection. Has the Wi-Fi been terrible for you as well?
Yeah.
Okay, so attendance. Alexander?
Here.
Aria? Ariel? Yep. Ariel?
Here.
Charlotte?
Here.
Zhao?
Yeah.
Eric?
Here.
Guy? Isaac?
Yeah.
Isabel? Jessica?
Yeah.
Katie?
Yeah.
Kiona?
Yeah.
Natsuho?
Yeah.
Sihu? Sterling?
Yeah.
Jaden?
Yeah.
Tom?
Yeah.
Tyler?
Yeah.
Oh, fantastic. We're all here. Which means... I can... Back to lunch punch. What are you doing? We want B block. We want the special toolkit. Nice. Grab your partner. Grab a whiteboard pen and get ready at the whiteboard with your partner. Grab whoever it is. Find out someone else's name. Pardon? Grab your partner. Go to the whiteboard. Get ready. You might need a period. That's a good point. You'll need a periodic table. Find your partner for. You have your partner? Partner? No. Okay.
Oh, are you aligned? You're with Sterling.
Sterling, where are you?
Yes.
There's your partner. You look very confused.
Oh.
Good? Everybody good? Because there's nothing students like more than randomized partners first thing on a Saturday morning where you have academic classes. Returning students, you might find this amusing. There was a student in Privet House today who didn't know the school had Saturday classes. They applied, got in, and they were just like, oh, do I go back to bed now after number one inspection? Like, no, you have academic classes. And they're like, what? We have school on Saturday? Yeah. Oh, actually, they didn't. They had to do an emergency leave. So that actually makes sense now. Okay, we're going to go back to, because we skipped a page. You can do it right on the board. I would like you to draw the Bohr model of boron. Label the electron shells, the electron energy levels, the outermost shell, the valence shell, the valence electrons, the inner energy levels, and the nucleus. I do recommend you do not draw it to scale. So this is their Bohr model, but with a ton of labeling. You need to get more whiteboards. This is a bigger class. Has anybody seen one of those movable whiteboards, like lost in a hallway somewhere around the school? We could steal it? No.
You mean borrow it permanently?
Borrow it temporarily for a little while.
For the class, for the year.
Yeah.
For the year.
Oh, I know what I could do. They're not that big. However, if you are crowded out where you are and you can think you can draw something this small, you can come back here. label names, but looking away. Really? It's like knowledge.
Like Rusty? Oh, this is really bad. Oh, this year I'm gonna make sure. Like volleyball Girl Scouts.
So first thing, draw your Bohr model. Looks like everybody's up with that. Has everybody got the electron shells labeled? The electron shells. So we've got electron shells. We got electron energy levels, which is almost a trick. The outermost shell, the valence shell, and the valence electrons. Then the inner electrons, inner energy levels, and label the nucleus. Nuclear. Nuclear. What are you doing, Eric? You look like you're just thinking or looking at your feet. Thinking. Excellent. Good man.
Isn't it just a
You should be doing a neutral atom, yep.
So wait, is it like the inner energy level? Do I just say
Yeah, outermost.
like -2? Like since it's already neutral.
There's no, a little hint, there's no like -2 or anything with inner energy levels. You're making it actually more complicated than it needs to be. There's a bit of a trick. Some of those things are named twice because they have two names. And so I'm just seeing if you know which things are duplicates. So, in the same way you did valence shell and outermost shell, there are other things that are also duplicates.
Have the same amount of electrons and protons, so it's neutral.
Once you've labeled everything, you can have a seat. What's going on here? You can. I was meant to teach the voices because some just don't know how to tie a tie. Pardon?
Still don't know how to do it.
Oh, well, we're going to show you. But there's a simple way as well, in which you just go like this, swing it twice, and then you reach through and pull that up in between, and it falls, and then you can just put that on. And now you have a tie that you can just like throw in your head. Yeah, yeah. Well, that's the normal way. This is like a super fast way. Also, sometimes it looks like it went around, so you have to like move it back in.
Yeah.
But it worked. Okay, let's see if we have all the things. We agree on 5 and 6. That one's got valence electrons, valence shells with valence electrons. This one seems to have an extra. Did you mean to have a whole extra shell?
I mean, that was like a label. Yeah, we just moved from.
Oh, that was okay. So you're labeling that because the valence shell is the shell where the valence electrons are, inner electrons, inner energy levels. So these are all electron shells, inner energy levels, and outer energy levels. Outer energy levels are always the valence shell. So there's two words for one thing in there. That was the only purpose of that. An energy level and a shell are exactly the same thing. When electrons are in certain shells, they have a certain amount of energy. So those terms are interchangeable. Yeah, did well. first thing on a Saturday morning. Electron shells, everybody had the 2, 3. And there was one of the back shells. Boron, fine, excellent. And this time, everybody drew it the shortened way, which made it a lot easier to see. There's nobody absent, so the live stream probably will not ever be used. But I'll put it in here just in case you're looking at it for studying later. If you want to get it down in your notebook for your future quizzes so that you have them as a permanent record. So, we got the nucleus. Oh, did I check? Did everybody? Yeah, everybody labeled the nucleus. Outermost shell. Or valence shell / level. Inner shell / level. Valence electrons, inner electrons. Inner electrons. Valence electrons. Did I forget anything? What? I don't think I did. Okay, little review there. Now we did all the way up into isotopes. And we did the World War II story. And, oh, I don't think we did. Calculate that. Reminder from last day. What number is that?
238.
It is 238.
It's the number of neutrons.
No. It's close. You get the number of neutrons. You use that to get the number of neutrons. It's neutrons and
Mass.
it's not the atomic mass.
Protons?
That's, no. Here's the, oh, well, you identified one. That's the number of protons. So that is the atomic number. It is, the atomic mass is an average of this.
Oh, mass number.
Mass number. So that's the mass number, which is the number of protons plus the number of neutrons. And for each one of those, why don't you quickly calculate the number of neutrons? Did I do the World War II story last day?
No.
Okay, while you're calculating them, and I'll ask two people in Class Dojo in just a second. Which one's the dangerous one? 235.
46.
When you're trying to do shielding and you're doing research on uranium-235 and 238, they tended to use heavy water. So they had H2O as a shielding because you could pump it in and pump it out. But they would use it, and it would be hydrogen with an extra neutron, so it would shield a little better, and you'd use it in different experiments. It is difficult to get. It's present in, it's extremely rare in regular water. So there was two groups trying to build the first atomic weapons. Of course, we've seen the film of Los Alamos and the Allies. But there was another attempt that was simultaneously going on by the Nazis. And we didn't, and the Allies, I say we, I wasn't there, the Allies didn't know where they were. And they wanted, of course, to slow them down. So they looked, they knew that they would have to be somewhere with a lot of power, because you'd need a lot of power generation in order to do all the experiments. Then they need access to a lot of water to filter out the extra deuterium water. And they also know there'd probably be waste. So they look at, they send out all their ships into the world. Now let's see, here we got, what's that? It's Africa. And here's Europe. And there's Canada. And there's the United States-ish. South America. There. My geography skills are terrible. I was a full adult before I knew that Korea wasn't next to Norway. Because I thought that region of the world is where all the peninsulas were, obviously, because the teacher, I thought, told me that. I'm pretty sure I was wrong and I just was mistaken, but I just carried that belief with me. I always wondered how all the peninsulas got there. Turns out they didn't. Anyway, So they just told their ships and their submarines, take samples of water wherever you go. And they found in the Straits of Norway, there was water present that was heavy water. It had hydrogen that was made out of deuterium in much higher amounts than it should be. Instead of being parts per trillion, it's like parts per million. And so they know there's some effluent in Norway. So let's make all the coastline is rough. There's a stream running down Norway and some towns. And there's a dam. And they go, that would be a perfect place for a research facility. I'll bet you it's there. So they got an airborne group to parachute in, and they would have to parachute on this side, and they're going to get them to blow up the dam. That'll slow their research down. They'll have to move facilities. So they parachute in, and they land here. Curses. What did they do? No, they found a cave and they died. Because first objective, blow up the dam. If you cannot blow up the dam because you're on the wrong side, don't get caught because then they'll know we're coming. So they just found a cave and they hoped that nobody would find them and maybe they'd get rescued. They didn't, they froze to death. They couldn't even go to the towns. They could have gone to the town and surrendered, but then they would know that the Allies were coming and either, protect it or get more reinforcements. So they just went into a cave. So they're gone. And they sent in another group. And they do land on the correct side. Avoid the town, go into the dam, blow up the dam. Slowed research, they estimate, by 7 to 8 months, which is why one of the two reasons why the research was probably delayed on either side. The other reason is that on the Ally side, one of the chief influencers on the research was an engineer. And they knew that if you want to make things efficient, you put them into spheres for packing. On the Nazi side, the chief researcher was a physicist, like a theoretical physicist, and they did all their calculations not with spheres, but with cubes. So they put everything into cubes. Why would you do that? Why would you use a cube?
Easier to calculate.
Pardon?
Easier to calculate.
Easier to calculate. He wanted his numbers to be simpler. So that actually slowed them down by some amount of time. And that is one of the reasons why the history was a little different in some ways. In terms of dark alleys and spycraft, they sent people in and it actually slowed them down. Okay, atomic mass versus mass number. This is just to let you know. Let me grab, where's my sheet? Just to emphasize the point, what's the difference between mass number, and I shouldn't probably abbreviate a title, this is of course an average. It doesn't have to be an integer, whereas the mass number has to be an integer. Mass number is personal, it's for that atom, and if you have it, you must use it. If you were the Canadian government and you are getting supplies or a resource or a benefit for Canadian families, you're going to use the number 2.3. But if you're going to someone's house and it's a potluck and you're bringing food, you're going to use the number of people in their family. If you know the number, use the number. Bromine, for example, has an atomic mass of 79.9. No single atom of bromine has a mass of 79.9. In fact, this is one of the differences. The only two real forms of bromine that exist in large amounts is that there's bromine 79 and there's bromine 81. So if you use the estimate of 79.9, you're like, oh, I'll just round it to 80. This is actually one of the cases where you get it wrong. There is no bromine 80, it doesn't exist. There's only bromine 79 and bromine 81 and roughly 50-50 details, and so we just end up using that. It works as an average if you're dealing with a lot of bromine, but if you're working with atoms, and specifically experiments in which you have to consider the actual atom, then of course you want to use the actual ones. Because I showed you last day how it corresponds to a number, if you weigh out that many grams, that means you know that how many atoms it has. It has 6.02 times 10 to the 23rd. So if you weigh out 79.9 grams of bromine and 1 gram of hydrogen, they both contain the same number of atoms. So if you're trying to make HBr, then you just know you need to go to the store and I'll buy 80 grams of that and 1 gram of that, and that'll be just enough. This is lighter, so I need not a lot less. If you were going to the store and you wanted to make pure water from scratch, then you know you need to get 16 grams of water and 2 grams, because it's H2, of hydrogen, and you'll make 18 grams, and it'll all be used up because these contain the same number of atoms. Ooh. You need that partially filled in, and this is where I do need my sheet. Where did I put that down last day? Or maybe I should have started on the other. Did the person who came in here and cleaned up so nicely steal my stuff? Anyway, turn to that page. I'm going to have you fill in the different columns. Maybe I'll just make it up. Oh no, this seems to be it. I accused them of cheating, but it was actually me. So, this will be quick. We are going to say this is oxygen 18. What numbers should I put in? Chlorine 58. $31. Let's go for this one. Let's go with 6 and 7. Oh, I'm going to hurt it. 7. Next one, let's make it 22. And you will also need 15. Selenium 34. Lithium 7. Okay, those are the ones I've given you. I will go through the top. If it's oxygen 18, what's its atomic number? Hey, because you can get that off the periodic table. How many protons does it have? 8. What is its atomic mass? It is close to 16. 16.0. We do include the 0.0 just to show that it's a decimal. What's the mass number?
You know, 18.
18. Because I gave you that. So if I give it you that, you have to use that one when you do the next one. How many neutrons does it have? 10. Now, if I didn't give you that, you might assume 16 and do that. Number of electrons? 8. Has to match the number of protons. These are all neutral. And the symbol. I want you to do the full symbol. So, oxygen, 18, so that you have the whole thing. And if you want to be very clever, you can put the number of protons below it like that. Fill in all of the columns or rows, whichever way you want to do it. Should I put you in pairs again and make you do it on the board? No, probably not. Might be a little crowded. You would like that. Let's go to the board. I'm just trying to think of the table. 1, 2, 3, 4, 5, 6, 7. I know you don't know. It's gotta be 1, 2, 3, 4, 5, 6, 7, 8. Here, right? 14, 58. Okay, now one around. See what you're doing. Questions, confusion? Yeah, because they're the same. Yeah. One of the reasons I do the table like that is you go, oh, they're the same.
What?
But that's always math. Can we round it to a whole number or do we do
Questions, confusions?
Sorry, 35.5. We just rounded to 36. Or does he want?
Yes. Yes. Yeah. If you know it, that's what you have to use. If you don't know it, then you estimate it.
Let me see. Oh, whoops. Are you sure it's 33?
Questions, concerns?
58 minus.
For the atomic mass, yes.
Alright, but then
Atomic
when you
masses,
calculate,
But nothing else.
mass
Pardon?
number
when you
minus.
calculate like neutrons, can we just make sure?
Well, you would have to, but when you calculate neutrons, you're not going to use the atomic mass. You're going to use the mass number.
Oh yeah.
Because that chlorine is like insane.
What's
You doing okay? Where would you rate the 31? Yeah, that's where the mass number goes. When you ready to be simple.
Come on. Not that hard, but it's 40.
What's its mass number? Right, so that's the one you use. Always use the mass number that you gave it. So I very deliberately gave you a chlorine that is to the same, because it should be around 56, but it's actually 58. It's got way too many neutrons. How are you guys doing? Are you awake?
Calculator. How did you write one as well? Don't call it a calculator for no. 58 minus 70.
It's not 15.
So
You don't even carry over. You don't even carry over. I told him the answer was
Okay, time.
oh my days.
so you're not getting
Not a
any
tree.
information. Then you put, you're not getting any information.
Coming to
But you're given the information, that's the information given. How you guys doing? How are you doing? Doing good, good. 41 there? How are you doing? Why don't you have that? I think I have extra ones. And you can just, and then stable it together.
Wait,
Make it a
excuse
little
me.
faster. I printed way too many because I didn't know how many people would be in class to begin with.
How are we supposed
I do.
How are we supposed to find something? What? Assume.
fact, why is it on there? Now, I will try to. Anybody done? Are you done? Okay, I can't do that. All right, who's ever left?
Nope. The master. You just assume it's 700. That's what you said.
That's what you said earlier. I think so.
Oh, alright.
So, how should we solve this one? I mean, with no mass number.
Then you have to look at. You have to assume.
Just guess.
No. Because
But it's not sure.
If you have the mass number, you have the mass number. If you don't have the mass number, you lose the count. So you just write 79 again.
You sure?
Yeah. I think so, but it's like new. I haven't opened it yet.
Because you don't make mistakes.
It's like I don't know.
It's a compliment.
Yeah.
Wait, bro, what's your name again?
Neutrons is an apple number.
Alright, are you gonna take any? Why aren't you taking the AP science?
Maybe sciences. I just can't enjoy school. What's the point? I can show you my test.
No, I would want to too, but my mom is making me take it. Yeah. Yeah, my mom got me this second.
So is there grade 11 or is there grade 10 AP?
No.
No.
They're all kind of grade 11 classes, but you can take it like, if you're doing
I'm really taking AP science.
yeah. It's not chill, but it's like not that bad.
Yeah. It's just
I think like when you just need to do like it's like
yeah.
it's like writing essays. But I'm doing like AP macros and like yeah. But AP macros kind of free, you can just take the test. But micro you probably need to take the class because it's more like the English.
Oh my god.
Yeah, English is chill. Oh no, I'm taking first thing I'm just gonna take the test. I'm studying, bro.
Okay, we'll use a different color. Hopefully your phone should not be out at any time, Charlotte. Phone, no, put it in bag, far away. We'll use a different color. I think you can take a couple, actually you can take 3 people at the same time. So when you, I'm going to ask you to come up and fill out 2 boxes. Your choice is the boxes, first come, first serve. You can use the pen, but it is also works with finger. Please don't use your nail, just your finger, so you don't scratch the board. 2 boxes per person. Come and fill it up. Go and fill it any 2.
I'm gonna take this.
Oh wait, we can fit with our fingers. That's actually kind of cool.
Yeah, I love fingering this board.
Okay, you're weird. That's not a weird buddy.
No,
No wonder everyone calls you homo.
What? I'm not homo.
I'm joking.
I'm not gay.
Whatever you say.
Never mind.
Oh my god. Yo, who just did that? Yo, who just sabotaged my work?
Where's your ASIC from?
How? I don't want to.
Is neon?
Because then everyone's gonna
Oh
erase.
yeah, that's true.
No. I'm not.
Wait, you're good at math? Yo, bro, it's the Asian gene. There's nothing else. It's the good genes. Bro's blessed.
I think like I haven't seen Asian that's not good at math except if they're whitewashed.
Yeah.
Like this.
Like
guy.
me.
Not like this guy.
Oh, okay. You're bad at math, buddy?
I want to.
12, right? Is that correct? This is 6. Nice.
Yeah, actually. Who do you have? Oh, okay. I have this with you. She's so chill. She's actually so. I don't care about her. Yeah. Yeah. Yeah, that as well.
Pre-calc is so. Wait, you know there's AP pre-calc?
That feels good.
Are you?
Like,
I don't want to. I don't know if I should take it or not. I know it's like a free AP class, but like it's
Hey.
kind of pointless.
Yeah.
Oh, what he has
Ooh.
is that a dedicated GPU?
Yes. However, I think in the move it got fried. It's old. It's only like a 1070 or something.
Oh, 1070.
Yeah. So it's old. But I think in the move it got fried. It's not working properly anymore.
see.
So I got to take it apart and see if I can fix it.
I see.
Okay, if I can get your attention.
What's wrong with that?
Just a couple of things. So I think my examples may not have been clear enough. When you write out the name, you always put the mass number after it if you're going to do that. So oxygen 18, chlorine 58, phosphorus 31, carbon 13. So a dash and the number is always the mass number. Neon 22. And so if you didn't do that, add that in. Although it might have been felt a little squishy. Selenium, what did that turn out to be? Oh, we don't have it down there. I think it's 79. We add those 2 up. As you may have noticed, these 2 columns should be absolutely identical. What other column is absolutely identical to the number of protons? Electrons. So these are, of course, also identical because we haven't done charges yet. We're going to do that next. So if it's an atom, maybe I should add that to the bottom here. Whoa. Add that to the bottom. Atoms, no charge. The number of electrons equals the number of protons. Questions? Next one, all of these should have a decimal. I think it's looking pretty good there. The next one should be the mass number. That should be the protons plus the neutrons. So in each case, it should be these ones added up together. 7 to 7 is 14, so that should be 34, I believe. Hold it. I added the wrong 2 things. They also don't have the neutrons there, so that didn't quite get filled. 58 minus number of neutrons is 41, which is an insane amount. This chlorine 58 should be incredibly unstable. So what would the mass number then be for this? 58. So that is a bizarre. And that looks good. That one I think looks good. This one looks good. Check your own answers. Some of these are a bit squished. Is that a 22 or 3? That should be 22. 79 selenium. That one's good. What's the mass number for this selenium? 79. The protons plus neutrons. We had to estimate it. And we're good. Excellent. Okay, next page. Now we're going to add in charges. Oh, I should say, before I get too far ahead of myself in case the bell goes, we have, you have a quiz next week. What is the quiz on? It's not going to be on what we've done today because there's no prep after today. Just so you're aware, technically speaking, you cannot be assigned any work on a Saturday that is due on Monday because you don't have a prep in between. So if your teacher assigns you something due on a Monday, it had to have been at the very least on a Friday, because then you would have Friday's prep to do. Some teachers might do it anyway, but you have a legitimate right to complain at that point. And that's generally my rule as well. If I tell you way in advance, like you've got all these preps, it's going to be due on a Monday, then it's due on Monday. I'm probably giving you extra time to come and see me for extra help if that's the case. What our material is going to be, so everything we've done today, I gave you a lot of definitions at the beginning, like what is an element, what is chemistry. We've been able to draw a Bohr model several times, so I'm going to expect you to be able to draw a Bohr model. We classified matter. So if I gave you examples, you should be able to pick out what types it would be. You would know the subatomic particles, and you would know definitions like atomic number, mass number, those types of things. But you wouldn't be able to necessarily fill out that table, so I'm not going to give you something like that. But I could ask you to do a Bohr model or draw something or do anything with those definitions. Okay, atoms and what's negative and positive and how do we get charge. So what's negative? Electrons. And we have a positive nucleus due only to the protons. And it's overall, for an atom, it should be neutral. As I just said, because the protons equal the electrons. And so, that's neutral. Which one, if it's becoming positive, which one do you get more of? The protons or the electrons?
You lose electrons, right? Electrons go away from that, huh?
You don't understand. When I say which one do you get more of, I'm waiting for a student to give me the wrong answer, which is you get more protons. And then I go, aha! You can't move protons around, and you went straight to the right answer. Well done. You can only lose or gain electrons. And electrons are negative. So if you're gaining electrons, you become more negative. If you lose electrons, you become more positive. The protons that are locked away in the nucleus don't do anything. Oh, right, I'm not using my magic app and calling out people at random. What are charged particles called? Let's go with come on, load. Oh! See who you were saved by the bell, unless you can tell me what it is. Ion, perfect. And then we have specific names for positive ones and negative ones, but that's good, excellent. So, quiz next week, only what we've done this week up till Thursday.
I know
Where did my monkey go?
I'll ask him that.
If you have questions, don't forget there are tutorials on Tuesday.